All right, today we're going to be going over compound inequalities again, but we're going to change things up a little bit. So it's not a different type of compound inequalities. This is just a different way to represent an and inequality. But we're going to go over how to do this like kind of three-section inequality. You may notice that there are two inequality signs in this whole thing. So that means that there's a number over to the left, a number over to the right, and then there's more of an expression in the middle of this. So we're still doing the same kind of work as before. We're going to be solving for n, but it's going to be a little bit different. So before we do that, I did mention this is another type of and inequality. You could represent this as negative 42 is less than 6 plus 8n, and 6 plus 8n is less than or equal to 78. So one way that you could do this is by taking those two inequalities, solving them, and then combining them like you would before. But we're not going to do that. We're going to do a different way to solve this. We're going to solve this all together. So we're going to consider this all like one equation, because it is. So we start by solving for n. So we're going to subtract, in this middle bit, we're going to subtract the 6. We still want to get rid of the stuff in the middle outside of the n. And since we're subtracting 6, that means we have to subtract 6 from the other side of the inequality. Well, there are three sides or three sections here. So we have to subtract 6 here, and we have to subtract 6 there as well. So it cancels out in the middle. This becomes negative 48 less than 8n less than or equal to 72. So now all we have to do, we're solving for n. We have to get rid of that 8, so we're going to divide by 8. Again, we do that to all of the sections. Divide by 8, divide by 8, divide by 8. That cancels in the middle. So we have, it's negative 6 is less than n is less than or equal to 9. So in this inequality, those are the things that we would get. If you were to solve this all the way out, you would actually get negative 6 is less than n, and n is less than or equal to 9. So you can see how when you solve these, you get basically the same kind of answers we do here. Now, when we graph this, we're going to have one graph that represents the whole thing. So we have a point at 9 and a point at negative 6. The point at negative 6 is going to be open because we do not have the line under that. That's not equal to. And this one over here, that's going to be filled in. And since n is less than 9, we're going to have a line that goes this way. And it's also greater than 6. We're going to have a line go, or negative 6, we're going to have a line go this way. And we can see how n is actually between those two values. In this equation, it's less than that one, greater than that one, and it's between these two values in our graph. So this is a graph that represents that expression. We're going to do another example kind of like that one. This one has a negative in front of the variable, so it's going to be a little bit different, but not a whole lot else is going to be. So first step, we're going to add 10 to both sides. In this case, that means adding 10 to all three sections. So negative 90 plus 10 is negative 80, less than negative 10a, less than or equal to, here it is, negative 10. Got lots of negative 10s there. And then we're going to divide by negative 10 to get rid of that in the middle. Divide by negative 10, divide by negative 10. You may remember that whenever we divide by negatives within an inequality, that means these inequalities symbols have to flip. They have to go the other way. So we're going to do that as well. Negative 80 divided by negative 10 is positive 8. A goes in the middle. That one flips as well, and that becomes positive 1. Now we need to think, is it possible for for some number to be less than 8 and greater than 1? Well, that's true. There are plenty of numbers that are less than 8 and greater than 1. So we can graph this one, draw the line, and so obviously 1 goes down here, 8 goes up here, put them in order. This one's going to be filled in. That one's going to not be filled in, and we connect them because it's greater than 1. It's on this side of the bigger side of 1, and it's less than 8, so we have the stuff that's in the middle. All right, finally, there we go. Finally, we have this kind of example. This one's going to come out to a kind of different answer. So again, we're going to solve that inequality. We have only one thing we have to get rid of, so we're going to add that 2 to all 3 sections. And that gives 6 is less than p less than or equal to -5. Now, in this example, we have to graph all of the numbers that are less than -5 and greater than +6. Now, if you think about that, that should probably not really make that much sense, because there is no such number that is less than -5 and greater than +6. If we graph that on the number line, we're asking for, 6 and -5. We're asking for the numbers that are both in that direction and also in, make sure I fill that one in, also in this direction. So again, this is an and problem, and we have to think about what part of these two lines connects. And again, they don't. So this means we have no solution, kind of like we did yesterday. So that's the same kind of example. You're not always going to get a short line with 2 dots on either side. Sometimes we're going to get no solution. So in this case, we have to think about how these values are both going in the different directions. So make sure before you graph your thing, make sure that your answer actually makes sense in context. And if it doesn't, then we can have no solution. Thanks. Good luck.